And what we're going to talk about today are if, else if, and if statements. So these are just logical things that can happen. So for instance, if I wanted to print something out, like right now I have an integer, x, that's equal to 10. And I want to write something like if x is greater than or equal to 100. Whenever you write if, you need to have a condition. And in this case, the condition is x is greater than or equal to 100. And when that happens, that condition, something is going to happen. So normally, what we do is we put a couple of curly brackets here, and in between, we would print it out, or we would do something else. In this case, I just want to print x, and I'll just write is greater than or equal to 100. Right now, let's say that that's not true. X is not greater than or equal to 100. What kind of number would it be then?
Less than.
Less than.
So give me an example.
99.
12, 99. These are all great. Now, for now, we'll just have the two conditions. It either is, this thing is either true or it's not true. So if you got an if, then if the condition for the if is not true, then we need to put an else. What happens if it's false? Well, then maybe we want to do something else. Maybe we want to print out x is less than or equal or less than 100. Now, when I run this code, both of these print statements are going to print out. Only one of them. It's called data control.
Missing semicolon on the.
Oh, good call. I was about to run it and it wasn't going to run. So in this case, even though there's two system.out.println statements, only one of them is going to print. Which one's going to print in this case?
The second one.
Else, because x is equal to 10, which is less than 100. Now, what if I wanted to be a little bit more specific? Like I want to put a third condition in there. Anytime you've got 3 or 4 or 5 conditions, you can, but you need to put it between the if and the else, and you would want to use else if. So I'm going to add one condition here, else if, and I'm going to say x is greater than, I'm just going to leave it as greater than 150. What do you think I should print out in this case?
I'm better than 100.
Say it again.
I'm better than 100.
X is greater than 150. Now here's a tricky question that you may or may not know the answer to right at this particular moment. Let's say I have a number like 170. Is x greater than or equal to 100?
Yes.
Is it also greater than 150?
Yes.
Which one of these will run, or will both of them run?
It'll be the first one. X plus is greater than or equal to 100.
So you think it's going to get into this if statement here, and it's going to stop?
Yes, because else if only works if the other one isn't true.
Okay, that's one opinion. What do you think?
I think I agree with Anand because when it returns a value, that's where that function sort of stops. So once it satisfies that condition where it's greater than 100 and then it prints it out, that's basically that program is basically finished running for that section. So it's not going to keep going through the else if and else. It's just going to stop wherever it returns the value.
So you agree that it's going to say, okay, x is greater than or equal to 100. It's going to run that code, and then bam, it's done.
Yes.
All right, Jackie, what do you think?
I feel like it would have to check through each. So since it goes like top to bottom, I feel like we'd have to check through each line of code, right? And it's gonna do the one that's most recent, especially if it's an if else statement. So I feel like it's going to be x is greater than 150.
I think that's a perfectly logical thing to believe. Let's see which one of us is correct.
I don't like the word believe. I feel like I'm going to be wrong.
That's one.
170 is greater than or equal to 100. So what? Even though your reasoning was perfect, and it made a lot of sense to me, what Java's going to do is it's going to find the first condition in a list of if, else. It's going to find the first one is true, and then it's done. It's going to kick out. So it's going to read that first one, even though 170 is greater than 150, it's never going to get there because it's going to say, oh, greater than or equal to 100, it's going to run this line, and then bam, it's done. It does the first one only. That's true. Yes, Neil.
So this is the reason why like structuring your if statements is super important.
It's right.
If,
Right.
if it's like if this like else if you could have maybe just switched them and gotten a better outcome.
Right. If I put x is greater than 150 before x is greater than 100, that would make a lot more sense in this case. I think you're right, Neil. So let's go ahead and do that and see if it changes the outcome.
Couldn't you just also remove else from else statement?
How do you mean?
As in, instead you would have if x is greater than, well, else.
Okay, this is different. But wait, there's no else then. There would be an else for the other if statement. So it would be this one. It would just print it out. And it would be.
All right. So Neil suggested I switch them, which I've done. So what's going to happen now?
It'll be 170 is greater than that.
Okay, which is correct. So now it's operating the way that I want to. So yes, order matters because it's always going to do the first one. That's correct. Now, there's something we can do, and I'm just going to make this a little bit simpler here. That's called nesting ifs. This is where this gets a little confusing. It's really easy if they just line up and they're at the same indentation level. But what if I wanted to accomplish something like, oh, what if x is greater than 150 and something else? Like if x is less than 170, then I could have something like x is between 150 and 170. All right, so this is called nesting ifs. What would be the else in this case?
Else x is greater than
Greater than what?
150.
Not 150. Oh, yeah, it's greater than 150, but it's greater than, it'd be 170 or greater, wouldn't it?
It would be less than 170. It's like
Well, if it's less than 170, it's going to this one. And if it's greater than 170, it would go to the other one.
Oh, I read that wrong.
yeah.
Greater than or equal to.
Your screen froze.
You got it froze or you're not typing?
I'll fix it.
Oh. Well, that's the end of the YouTube video, guys.
No, it's going to have hiccups just like it always does. So if I pick a number like 180, what should print here? In theory, if I put my semicolon, happens every time I record. You know, in Python, you don't need semicolons. 180 is greater than or equal to 170. Now, this can get real confusing when you're nesting if statements like this, because then you've got different indentation levels, especially if you have like 3 or more conditions. Yes, Daniel.
So in the ones that you indented, the if and else statements, you didn't use curly brackets.
Yeah. So Daniel says, hey, look, didn't you forget to put these curly braces here? Or curly brackets, whatever you want to call them?
If it's one line, then you don't need them, right?
Say that louder so the people in my video can hear it.
If it's one line code after the if statement or else statement, then you don't need to put curly brackets.
That's right. If it's only one line of code, you don't need to put them, but I want you to get in the habit of doing it anyway. It makes the code a little bit cleaner to not include them, but there are going to be situations where you want to put 2 or 3 things after there, so you should get in the habit of putting them. But you're exactly right. If there's just one line of code, you don't. They're extraneous. But you should still get in the habit of putting them because it's good form. All right, but this is too much for me. Like there's too many things going on. This is hard to read. So we can simplify this code using something called Boolean Algebra. And Boolean Algebra is just and or not. Who knows the symbol for and?
It's 2 ampersands.
2 ampersands. Most people don't know that word. So I can simplify this code by saying if x is greater than 150 and x is less than 170, then I can get rid of this if statement here. So go ahead and print that thing out. And then I could write an else if, change this to an else if x is greater than 150, or I could just change it to greater than 170, couldn't I? And that would accomplish the same thing. So sometimes nesting ifs can get a little treacherous just because there's so many things going on. And you can accomplish the same thing by using Boolean Algebra. And we're going to practice that a little bit today using double ampersand. That's and. Now, if you wanted, it wouldn't make sense in this situation, but if you wanted to change it to or is just two straight up and down lines. And the two straight up and down lines, you'll find it on the keyboard right above the enter key. It's just shift / That just means or. So if something and something else has to be true, that means you have to have two truths. Or means either one of these could be true. X could be greater than 150, or X could be less than 170. Only one of them must be true. The only other symbol that I want to show you today is the not symbol. And I'm just going to change this to not equal to. So you see that exclamation? That just means not. Anytime you see exclamation, just means very excitedly, not. That's what it means. So that would be X is greater than 150 or X is not equal to 170. So that, to be true, that would be anything that's not 170. All right, that's a little bit of Boolean algebra. Let's talk a little bit for just a second here about strings. I got a couple more things I want to talk about here. String.
Is the symbol for greater than equal to just that little mouth guy? Is it just that, or is that just meaning like
Greater than or equal to would need an equal sign afterwards. Great question. All right, now I'm going to simplify this code a little bit here. And I want to make a string. So we've done everything about integers. Now I'll make a string. Give me a phrase, please.
I like turtles.
I like turtles. You sure do, Neil.
Thank you.
Proud of you. X is I like turtles. Now,
I have a question.
Why are you into class?
I don't know if this is English, but below public static void, what is going on there?
oh, that is visual glitch.
I'm gonna be late.
Let me fix that.
Oh no, it's spreading. Yeah.
I'll fix it.
College. A lot.
It's going to be a great video. I hope lots of people watch it.
I'll put it on my Instagram.
Whenever you're dealing with strings, like you don't want to write something like if X is equal to, it would be remember for when you're doing logical comparison, equals, two equal signs for logical comparison. When you're assigning a variable, it's one equal sign. You wouldn't want to write something like this. That's not the way we compare two strings. And then maybe print out Neil likes turtles. That's going on the internet forever. Neil doesn't like turtles. This line of code sometimes works. It doesn't work every time. And the reason is that when you're doing logical comparison with an equal sign, it's not looking at the actual characters. What it's looking for is a location in memory. So it's possible that this string is stored in memory a different place than this string. Even though they're identical character for character, it might say they're not equal just because they're stored in different places in memory. So the way we get around that when it comes to strings, since we talked about strings last unit, they are objects. What do we do instead of equals? We use x dot equals. That's right. So I know we've already talked about it, but just as a reminder, whenever you're doing logical comparison with strings, make sure you're doing x dot equals. So when I run this thing, it's going to say, hopefully, that Neil likes turtles. He sure does. All right. That's just a little bit of a reminder. Okay, I think there's only one other thing I want to talk about here, and then we'll be done. The last thing I want to talk about is something called switch case. Okay, now if you find yourself, and this isn't actually going to be on the AP exam, this is just something that will make you a better coder. All right, so if you find yourself writing a bunch of if statements, so I'm going to go back to int x equals 40, something like that. if you find yourself writing a lot of statements like this, if x equals 7, else if x equals 10, and let's put really likes turtles. And I'm going to put one more in there just to show you how obnoxious this is. X equals 40. What is going to print out when I run this code? Dang, Neil, what's wrong with turtles?
They're so like green.
Some of them are.
Very green.
Neil hates turtles.
I see someone.
This code is a little clunky. I mean, look how many lines of code it did to just run this one little thing. We had a similar issue. Our code was very clunky when we did the Java Math Lab. Remember, we had them type in an option. It's like, if they choose this option, then I'm going to do this math. If they choose this option, we're going to do this math. And it works and it's fine, but it's kind of like when you're looking at the code, you're like, oh, it just doesn't look right. So there's a way around this to make it a little bit cleaner. And it's called using a switch case. And so I'm gonna comment out a bunch of this code here. The Nintendo switch case. I wish. And there's a faster way to comment everything out as well, but I'm just being lazy. I'm being lazy. Look, it's really easy to be critical in retrospect. You're still going. Hey, so what you want to do the switch case is you specify the integer, which is still 40, or you can specify whatever it is. It doesn't have to be an integer, but in this case, it is an integer. And what you do is you write switch, which is a keyword. You see it get highlighted there, and you specify which variable you're going to be switching. So in this case, the variable is x. I want to switch x. Then we're just going to specify the different cases, like x could be 7, x could be 10, x could be 40, or we could just have a default, which is our else statement. Now, after each of these, you just put a little colon here and specify what it is that case is supposed to do. Like print out, Neil likes turtles. Or print out, he really likes turtles. Or you print out what apparently seems to be the case. He hates those turtles. And you can see now that I've accomplished with 5 lines of code the same amount that it took me 19 lines of code to do before. It just looks a little bit cleaner. Now the thing about this, the switch case, is it's going to run all of these cases. It's going to go to the first one that's true and then run all of them afterwards. So it would say Neil hates turtles and then it says Neil doesn't like turtles. I don't really want it to do that, so you can fix that problem by using a keyword that we actually don't talk about until Computer Science 3, but it's easy. It's just break, which just breaks you out of this switch case here. And so this will do exactly what you think it's going to do. X equals 40, so it's going to say, hey, Neil hates turtles.
Wait, what does break do again?
Break just takes you out of the switch case. Otherwise, it's going to find the first one that's true and do everything after that. So if you don't put break there, it's going to say Neil hates turtles and then Neil doesn't like turtles. But if you want it to operate the same as an if, else,
You have to add break.
you have to add break. Yes.
Default means I don't. Wait.
Yeah, it's going to run, no matter what, it's going to print out this unless one of these other conditions is true. Yeah, default is like your else. Like something's going to happen. And it's going to be Neil doesn't like turtles unless one of these other cases is true. So that's not likely something you're ever going to be tested on. I don't think I'll ever put on a test, but this is just the sort of thing that would make you a better programmer. Okay. All right. So I'm going to end this video. Say goodbye.
Bye. Bye.